Welcome back to Element 14 Presents. I'm Clem, and usually when I find something awesome I have it in my hands when I come in here. But this time it's way too heavy. I got myself a Teletype. The device in question is a Siemens Fernschreiber S100 or Teletype S100, made by Siemens in the 1960s. And I'm wondering, could I interface that with modern tech? And to find that out, I would have to find the pinout for an 80-year-old device. How hard could it be? Yeah, 1960s, over 80 years ago. Oh my god, I'm old. But now, after realizing that, the first thing I always do with vintage tech is look it up on the internet. Do I find like listings on the classified ads? Sometimes you even find the user manual. I found a user manual for my unit, but it's not for that particular one because I've got the military version that was used by German and Austrian military, and it's like modded to 75 baud instead of 50 baud like the normal units, and it's kind of different. It's missing parts. So something funky is going on here. And the manual doesn't provide a pinout anyway, so we will have to do some reverse engineering. To start you off with this fascinating machine, it's completely electromechanical. So it's mostly mechanical, and then it has some electrics. Not electronics, electric circuits. Like a relay is the most miniaturized part in there, and it has a big honkin' 240 volt AC motor. So let's check out how this machine works on the inside, and then we go on to finding out the pinout. The S100 Teletype has two units on the side. These are like the big add-ons that you would use. And they use punch tapes, like this one. It writes in 5-bit Bordeaux code. And this one in particular says Element 14 Presents. That's what is encoded here. So if you read that with the machine, it prints out Element 14 Presents. And we will later find out what this code means. We are dealing with a machine that uses 240 volts mains AC, so we have to take some safety precautions. The first thing after not finding a valid pinout for the machine is finding where the dangerous bits are. So I use my trusty Klein multimeter and I probe all the connections very carefully, not touching anything on the machine, to find out where is the dangerous voltage and where it is not. So which are the signal connections and which are the power connections and how they interact with each other. First, I always try to identify the power regulation circuitry. In this case, it's a big honking transformer, and that has different outputs for different voltages. So we already know there is something going on that we have to be very careful with. Big AC voltages. So the writing on the transformer tells me there is 240 volts going in, or 220 depending on whatever you put into it. It seems to be tolerant between 220 and 240 volts AC input at 50 Hz, European continental standard. Then this transformer knocks that voltage down to 6 volts AC. That goes directly to a light bulb. So this light bulb is AC driven, so we know we don't have DC voltages in here. I couldn't find any rectifying circuitry. And then we have two other lines that are called TX 98 and 99 or something like that, and that's the telegraph line. So that is basically providing the base voltage for telegraph lines as they were used back in the 60s. And usually when you have these circuitries connected, then when the unit is not connected to a telegraph line, an active one, then it just types frantically away and you can't really stop it. Aside from putting the voltage it's expecting on one of those pins. Usually that's something between 70 and 110 volts. But this Teletype doesn't type frantically away, it behaves more like a typewriter, so you switch it on and then it does its thing. It is not waiting for any signals. So what's going on here? While probing around, I basically grew old with that. It took quite a long time to figure out what exactly is going on because A, I don't want to touch something by accident that could kill me, and I don't want to ruin the device. I don't want anything of this mechanical marvel to come out of sync, which is a risk when you start and stop it in unexpected ways, maybe by tinkering around with it. And I encountered that the sender and receiver circuitry is basically missing. And then I asked around by people who know old stuff, and it turns out that unit was most likely only used in an office as a way of copying communications decrees like letters and orders for military personnel, and not really on a telegraph line. So it's basically a stationary or a local teletype that was never intended to be connected to the telegraph line. So that circuitry is missing, and to be able to have input and output, we basically have to figure out how that circuitry would enter it into the machine. This device has a mechanical ROM. Yes, read-only memory. Like memory, like in a computer, but it's completely mechanical. And that is the address of the device. So if you would have connected it to a telegraph line and you press a specific button, it tells the other machine on the other side of the world or whatever who it is. It basically chants out its phone number, so to speak. But it has like a specific number for every registered device. And if you know that number, you can ask people that may have old registers with those numbers so they can tell you who was the original owner of such a device. And mine has pretty much a blank ROM. It only has the letters ZP and MM in them and no numbers. So what I think is that ZP is Zentralpoststelle or Central Postal Service, and the ROM never was set. And also it has like 2000 hours of usage on the counter. So maybe that wasn't too heavy in use. It's also in pretty good condition, apart from optics. First thing that I identified with the multimeter is the voltage rails. We have one contact that has always 238 to 240 volts. I think there is some voltage drop going on with the transformer and the cabling stuff, so it doesn't really equal the usual voltage on my power lines. So that is always on. Then there is a switch. If you push that one, the unit switches on, the motor starts turning, and then the other connector is powered, also with 240 volts or whatever is on the line. Then we have two blank ones that have a potential of 1 volt, possibly some residual current that is leaking around the device. And then we have another one that has the 6 volts AC for the light bulb. So the power section is identified. The other connectors on there are just blank and they have like a little bit of leak voltage on them. So like a little bit of potential difference to ground. So the tape gets read in and is not mechanically transferred to the base unit, which I thought was it. It's linked up mechanically, but it's only syncing the movement in. So the actual checking if there is a hole or not is synced to the rest of the machine, but then the data gets transmitted over a little coil with a little magnet inside. So that's basically a solenoid, a weird one, or basically an old one. And that activates 5 little rails on the machine itself, and those are basically the same encoding. So there are 5 strips of metal, and those encode again in Bordeaux code. And with another unit on the left, this Bordeaux code then gets mechanically transferred over to the right typeface. So the unit types only the letter that is set in this 5-bit Bordeaux code. And then it does the next one. And it's a serial protocol. So basically on a set pulse, these points shift and it syncs up these letters. So you would serially put it in and then the machine types. Yeah, we have to decode Bordeaux code down the line. So first I only started probing around with the multimeter. That gives me an idea of how high of voltages are involved. And turns out I couldn't measure anything on the input side, except when the device is active. That means when the punch tape is read in, then I could see some sparks. And that means the contacts are actually just closing. So every pulse that gets in from the punch reader closes this solenoid, basically, or activates the solenoid. And that is something that we can do with a relay. So what we have on this side is basically closing a switch. And if we try that out by hand, the machine types. Of course, we can't control what it types because that's not how I can control my fingers. But it does type, and that means we can control that with a relay and control that relay with an Arduino, for example. Using a relay makes us independent and isolated from the rest of the circuit. That means we don't influence anything else that is going on in there, and that's important because we don't want it to get out of sync. So the next thing that I tried is probing the other section. There are two other connectors, and I tried that with my oscilloscope to see what is going on here. I used the one-shot function and pressed one of the keys to make it trigger, so I could see what is put in or out on each of these sides. And it's pretty mysterious. I'm not sure if the keyboard is only encoded on one side and then it gets fed out, or if what I'm measuring is just like some intermediary signal that would then be used by the sending unit that is missing, and that would get transferred into a good signal, because what I measure is noise, but it's like distinct noise, so it's not there when I don't press anything, but I can't see the Bordeaux code in there. If I do that on the input side, I can clearly see there is Bordeaux code with a lot of noise. It's a noisy system, it's 80 years old, my god. But on the output side, it's pretty crispy, so I'm not sure what's going on yet. So after probing a lot around and trying to capture some inputs and outputs, I can now conclude I can pretty much easily make this into a printer for my computer for any project if I want to. So putting an Arduino in there, rectifying the 6 volts, stealing that off the light bulb rail, and then making it like print. That's doable if I can decode the Bordeaux code and make it talk at the required 75 baud. That should be doable. But on the output side, like making that punch tape go somewhere else besides that is, it's easier to bypass the whole thing and read in the punch tape directly into a computer. But if I want to use the keyboard, that's a bit different. So I haven't gotten any conclusive stuff on how the output circuitry works. It has sparks up to 30 volts, but I'm not sure if that is just accumulating noise from the coil. It probably is, but we have to have a safe interface. So we'll probably have to use an opto-interrupter and try to decode that somehow. Or the method that I don't really like, because it could waste a lot of this precious tape that you pretty much can't get anywhere anymore, and I have only one roll of it. You could basically write your programs on there, punch it into the tape, and then read it back into whatever homebrew computer you would like to use. In this episode, we tried to find out the pinout for an 80-year-old Siemens Teletype. How hard could that be? Turns out it's not that hard. We have to think about two things mainly: safety and how to interpret what we find with our multimeter and oscilloscope. We found that it uses pretty high voltages that can be dangerous, but it also accepts a little relay input for the data. So we have a really good chance of interfacing this with an Arduino. But on the output side, we're dealing with a lot of electrical noise. So we have to make some kind of filter circuitry and be very careful with how we interpret the data that we read. We found the pinout by trial and error, just with a multimeter and some additional experimentation with an oscilloscope. I would say it's doable for a beginner if you are very careful. I really would like to interface this device with another system, like a homebrew PC, maybe use it as a printer for my regular computer. I want to know your ideas. Leave it at the Element 14 community. The link is in the description. I'm curious to hear what you think we should do with that old Teletype, or is there any other vintage equipment you would like to see reused for modern purposes? Maybe we can send an email to some viewers. Let me know. I gotta go. There's another project waiting for me.